Okay, so today we're going to take the sequences, which is just a bunch of lists of numbers. We're going to figure out what the sum is. Right? And if it's a small list, like if there was only 5 terms in the list, I could ask you for the sum of it. Easy. What's going to happen is I'm going to ask you like for the sum of 100 terms or 200 terms or whatever it is. Okay? Again, 2 formulas. Do you have to memorize these? No. So there it is there. So there's a sequence. 2, 5, 8, 11, 14. What's D? 3, it says right there. What's the first term? 2. Could I ask you to figure out any term in that sequence? Yeah, I could. And that's the other formulas that we did. But then what I could do is I could say, hey, what's the sum of all those numbers? So if you look at the numbers, or look at the terms here, some of this should be the same. N is the, T1 is the first term, Tn is whatever the term is, D is the common difference. The only new one is S of n, which is the sum of first term. So if it was S of 10, you're finding me the sum of the first 10 terms. It's easy, right? Sum of 100, Sn, or S 100, finding me the sum of the first 100 terms. Okay, so let's do the, is it at the bottom of your page? Where is it? Is it the next page? I can't remember where I did the notes. Yeah, example number 1. Let's do that. Next page. Example number 1. That's not an example. There we go. Oh, from the example on the previous page, what is the sum of the first 15 terms? So again, what should we write down here to keep us organized? Okay, so let's do all the things. So what was T1? What was it on the previous page? 2. What is D? 3. What are we looking for? The sum. So we're looking for S of what number? 15. We're looking for that one, right? We're trying to find the sum of the first 15 terms. And that should be a dead giveaway, because if you look at S of 15, that's also known as S of n. So what the heck is n? 15. Okay. So n equals 15. Okay, now look at the formulas on the first page. Which one of those can be used? First one, because we know n, we know T1, we know n again, and we know D. Okay, so now we're going to write down the formula. So S of n equals n divided by 2 times 2 times T1 plus, in brackets, n minus 1 times D, close your bracket, big bracket. It's a complicated formula, but really, no. You guys have done enough formulas all through math to figure this out. Basically, we're going to replace all the letters with numbers, do bed math. Okay? So let's do this. Now, S of what? What am I actually looking for? 15. I'm going to put that there just so I know when I do my work, I'm looking for the sum of the first 15 terms. Okay, what's n again? 15 divided by 2 times 2. What's T1? 2. Now, don't see, hey guys, look, 2T1. Common mistake that students make, they forget the 2. They just put T1 there. They forget to multiply it by 2. Plus, what's n again? 15 minus 1 times, what's D? 3. All right. Yeah. And basically, if you look, we've replaced all the letters with numbers. Now, can we do the math? So what do you do for the math? Bed math. Yeah, we're going to do all the junk in the brackets first. But within there, what do we do first? The addition or the multiplication? Multiplication. So we're going to multiply this, the 2 and the 2, and this here, the 14 and the 3, and then we're going to add them. So I'll do one more line here. S15 equals 15 over 2 times, what's that, 4 plus, what's 14 times 3? 42. S15 equals 15 over 2, which is basically 7.5, times 46. Okay, 7.5 times 46 is, what is it? 7.5, 7.5 times 46. 345. 345? Now, here's an interesting question for you. Could we check this manually if we wanted to? Yeah, it's only 15 terms. We could actually figure this out, right? What would it go like? 2, 5, 8, 11, right? Could we do that and then just add them all up and see what we get for the first 15 terms? Yeah, we could. Do we want to? No. Way too lazy for that. Yes. So if you have a decimal like that, you go to math, right, and you go to fraction, and that'll turn it into a fraction. And if you have a fraction, you go back to math and go to decimal, and we'll change it to decimal. Or just do top divided by the bottom. Right, the easy way is just, if you put in brackets 15 divided by 2, like in brackets, it'll do it for you anyways. Yep. Okay. Easy? What do you think? Not that hard. And it really actually seems easy because we've already done arithmetic sequences, so really this is just a continuation. Skip example 2 for now, and let's go to 3. 2 is a real kicker. You're going to not like it, but it's kind of cool. I like it because it makes you think outside the pre-calculus box, right? It actually moves beyond. When you go to university, you're going to be doing a lot more theoretical thinking, which means thinking out here. Okay, let's go to 3. We'll come back to 2 in a minute. Oh, hint. Oh, I don't want that. Okay. Okay. Now, you guys have all been to the normal theater, right? Normally, actually, if you've taken applied, you probably did in pre-cal, right? This is actually a common question in applied, too. Normally, what happens in a theater is the first row has a certain number of seats. And then do they increase the seats as they go farther away from the screen or the stage? Yeah, because then more people could see, right? Okay, so the first row has how many seats? 22. What do you think just by coincidence, what do you think that is? T1, right? Is that the first row? Yeah, so T1 is the first number. Okay, so this here, T1 is 22. Each row after it has how many more seats? 2. So is this an arithmetic sequence? Yes, because it has a common difference of 2. It's increasing by 2. Oh, okay, so what's 2? C. Oh, awesome. Okay. Now, 22 in the first row. So how many does that make in the second row? 24. Then 26, 28. And how many rows are there? 17. So what is 17? That's n, right? So n is 17. What we want to know is, hey, if we were to pack this theater, like fill up every single seat, how many people could fit in this theater? So what are we looking for? We're looking for the sum of how many rows? 17 rows. Oh. Could we actually do this manually? 22 plus 24 plus 26. Could we do that? Waste of time? Yeah, dang right. Okay, so what we can do is we can figure out the sum. So let us, if there are 17 rows, what is the seating capacity of this theater? So we have our things here. What are we looking for? We're looking for S of 17, right? Isn't that what we're looking for? We're trying to find the sum of the 17 rows. So what do we do next? Write down the equation, the formula. S of n equals n divided by 2 T1 plus n minus 1 times d. Okay. Fill in the numbers. Let's see if you can do the math. I'll give you a minute or so to do it. Fill in the numbers. Do the math. Under 1,000, just so you know. If you get over 1,000, you screwed up. Where's your calculator? Pick it up. You need it. What did you get? 700,000? 646? Even if you haven't gotten there, you just check. It's 646. 646 people. It'd be a great experiment is actually go to the Western Centennial Auditorium and actually count the first row and see if that actually applies. Who knows? Sometimes they may add extra seats, but we should do some math field trips. What do you think? Sure. Okay. Yeah, we could go watch your movies. Not too many math movies out there. Okay, down.
Well, we're going to come.
Yeah.
There
you go. Now, sometimes when you get a question, and this is often the case with students, they go, oh yeah, I'm done, right? And they put the answer down. But sometimes there's second parts to the question. You really have to be good at reading questions. Often what I recommend is have a highlighter with you when you're doing questions. Don't highlight the book. Right? Like on a test or an assignment. Highlight stuff because there actually is a second question here, isn't there? How many seats are in which row? The 12th row. Okay. So you guys think about this for a minute. Are we asking for the sum of all these things? No, we just want to know, in the 12th row, how many seats are there? So this is not a series question. This now goes back to a sequence question, right? We want to know what it is. Ah! So sometimes you're going to have to use both formulas in a question, right? Series is for sum. Sequence is just the numbers, okay? So what we want to know is in the 12th row, like if we actually went, right, 22 in the first row, we could actually count this out, right? 24, 26, 28, we can count it all the way up to the 12th row. Lame. I'm not doing that. I'm too lazy, right? I do it mathematically. Okay, so we want to find stuff in the 12th row. So what are we looking for? T what? No, not just Tn, but T. We are looking for the 12th row. We want to know what is the number in the 12th row. Well, we need some other information, don't we? Do we need the first term? What's the first term? 22. That hasn't changed. What's D? 2. What is N in this case? 12, right? Because we want to know what's in the 12th row. Oh, do we have 3 of the 4 pieces that we need? Yeah. Let's figure it out. What do we do next? Write down the formula. Tn equals, we're going back to the other one, T1 plus N minus 1 D. My common mistake is I do this all the time when I write down. I always forget this plus sign here. I always just go T1 times N minus 1. I do it all the time. I haven't done it yet in this class, but I will. I guarantee you I will do it. It's a bad habit. Now you know you should get a number greater than 22, right? Because there's 22 in the first row. So figure it out. Plug in the numbers. Do the math. You got to be able to do this. Do you have a calculator? You have a calculator? Oh. What is that? Seats? Seats. Whiteboard? Not that hard, eh? Here comes the hard one. Example number 2. Oh, you'll hate this one. I love it, though. Don't worry, I probably won't give you one like this on a test. Like, questions that you're going to get on the test are going to be like this one, right? Like that, example number 3, perfect test question. Because it not only asks you one way, it asks you a different direction too, right? So it asks you 2 things. This next one, probably not good thinking because this actually, when you're learning stuff, right, there's a certain amount of knowledge that everybody learns. Everybody, 100% of you should be able to hit that knowledge. Then there's the next step of knowledge. Are all of you going to hit that? No, because that's sometimes too abstract for some people. I don't expect all of you to get it, but it's kind of an interesting question when we look at it. Okay, so, hey, get back up there. Does it work on your page? Can you remove the hints? Hang on. I don't think so. Dang, this new paper, this new technology just doesn't work. Okay, this is actually from the textbook. The sum of the first 2 terms of an arithmetic series is 13. Right? So term 1 and term 2 equal what? 13, okay. The sum of the first 4 terms is 46. So that's term 1, term 2, term 3, term 4 is 46. Okay? So you got that so far? First 2 terms is 13, right? So it could be anything, right? What could it be? 6 and 7, would that work? Okay, look, the first 2 terms of an arithmetic sequence, right? Or series in this case. First 2 terms, could it be 6 and 7? Does that equal 13? Could it be 5 and 8? I don't know. What else could it be? 4 and 9?
I thought it meant like the first one, 13, second one.
No. The first 2 terms added together, right? Because it's a series. The first 2 terms, the sum is 13. So it could be anything, right? It could be 1 and 12. It could be 0 and 13. Who knows, right? Could be a whole bunch of combinations. We don't know. So we could do this trial and error. Can you imagine doing that? And then picking those terms and doing the first 4 and seeing if they come up to 46? That would take forever. That would be like a really nasty puzzle, right? That would take forever. Well, what we can do is we can do this mathematically. So we can use our formula. So let me just write this formula down here for a second. Actually, what does this say here? All right. That's what's saying. Let's go back to the formula for series. So S of n equals n divided by 2, 2t1 plus n minus 1 d. Is that correct? That's our series. Okay, so let's do the first example and see if we can put in as much information as we can. Okay, so the first example is the first, how many terms equal 13? The first 2 terms. So what do I put there? Now careful. The sum of the first 2 terms is 13. So what do I put right there? 13. Right? You see that? It says that. The first 2 terms. The first 2 terms is 13. Now, the first 2 terms. So what then? 2, is that right? Okay, so, that's not bad. So we're getting, it's pretty good so far. Uh-oh. Do we know the first term? No. Oh, that's sad. Okay. Do we know n? What is it again? 2. Oh, hey, that's cool. I can put that in. Oh, do we know d? Ooh, sad. Okay. So we know some of it, though. And you know by basic math, right, when something like this, we did this yesterday, you can take these formulas and you can reduce them as much as you can, right? Remember, that was what was called the explicit formula or the general formula. Remember those from yesterday's questions? Where you took the big sucker, put in as much as you can, and reduced it down. And then you can plug in whatever n you wanted to get the answer. Well, we can do some of that with here. So what do we get? Guys, what's 2 times 2? That's 2 divided by 2. 1. So does that have anything to do with the rest of this? No, okay, so let's deal with the middle part. So 13 equals 2t1 plus, no, not just plus 1, plus d. What is 2 times 1? 2 minus 1. 1 times d is just d. So plus d. Oh. I could actually write plus d. That would help. Oh, wow. That reduced down pretty stinking nice, didn't it? Okay. Now, do you remember from grade 10? Substitution and elimination. Do you remember that? Do you remember where you rearrange something, one equation? In grade 9, you learned how to solve for one variable, right? Remember that? Algebra, right? You should learn to solve one variable. In grade 10, we introduced something called substitution and elimination, where you had 2 variables and you were able to solve for them. Do you remember that? Some of you are like, what the heck is he talking about? Right? So an example would be like, you usually had y and x's, right? You made something equal to y and then you plugged it into the other equation. Or you tried to stack them on top of each other and either added them or subtracted them to eliminate something, right? You might not remember that. We're going to do a whole big unit on that coming up. Like we really extend it. But this is basic. Okay, so look at this for a sec. Can I rearrange this so it's equal to d? Can I make it d equal to something? Basically, what am I doing? Moving the 2t1 where? The other side. It's positive, so when I move it to the other side, it becomes negative. Okay, you know that. Okay. So we end up with 13 minus 2t1 equals d. Okay, so that equation, d is by itself. Okay. Yeah? So far so good? Now, let's do the same thing again that we did just up here, but we're going to do it to the second part of the equation. We're going to do it to the first, what is it? 4 terms is 46. So the sum of the first 4 terms is 46. So write out this equation again, write out this formula again, the top one, but we're going to do it with 4 and 46. So instead of 2's, we're going to have 4's. Instead of the sum, we're going to have a 46. Okay, so do it again. You write it down. I'll write it down too as you're doing it. We'll see what you get when you get to this point. There's hard ways of doing this and there's easy ways of doing this. What's wrong? You're at this point now? Okay. Make sure you can get to this point at least. What? Heck, well, you can if you want. I just want to... Did you distribute the 2? Okay. Okay. Well, just give it a second because not everybody's here yet. Well, maybe everybody is. So what would you do in this case? Most common, right? You've learned that in the past, right? The distributive property. You get that 2 out the front, then you try to get rid of it. You distribute everything. But can you simplify a little bit quicker on the way? What on the right-hand side? What is in front here? 2. So could I take this whole stinking thing and divide it by 2? If I divide the right side by 2, what do I do to the left? Divide by 2, right? And basically, you're thinking about this. This is where you're moving beyond regular math, right? And you're starting to think about faster ways of doing stuff. You think about your rules of math and you realize, oh, I can do that, right? That's perfectly legit to do that. So basically what I'm doing is I'm dividing this by 2, so I divide this by 2. Is that correct? So those 2's are gone. Is that simplification? Yeah. 46 divided by 2 is 23 equals 2t1 plus 3d. Okay? Should end up with that. Well, that doesn't help us yet. Okay, now look at the last one. What did we do to the last one? What did we get isolated? D. Right? What do you think we're going to try to do on this one? Isolate D. Why not? So we're going to move the positive 2t1 goes to the other side, becomes negative. So 23 minus 2t1 equals 3d. Well, there it is. That's still not D by itself. What's attached to that D? A 3. How is it attached to it? When they're side by side, how is it attached to it? Multiplication. So then what do? We divide. Okay, now. Say what? Oh, yeah, but I'm going to do this by elimination. Okay, so we divide everything by 3, we divide this by 3, right? Those are gone. Now, in the past, you would have done 23 divided by 3 and put a number there. Now, guys, 23 divided by 3, is it an ugly number? It is so ugly. When it was young, its mother had to tie a pork chop around its neck so the dog would play with it. That's how ugly it was. Right? You don't want to do that, right? You don't want 23 divided by 3. It's a horrible number. And 2 divided by 3, 0.6 repeater? Oh, yuck. Okay, so leave it. Leave it exactly like that. Okay. So you got the first equation equal to D. You got the second equation equal to D. What do you mean, can you put them together? Have you guys ever talked about the logic? And I'll write this on the side here. Just don't write this down. A equals B, right? Something equals B. B equals C. Therefore, A equals C, because they both equal B, right? Have you ever seen that logic before? That's the basic principles of mathematical logic. Okay? First one equals the second one equals the third one, so the first and third have to be equal. Okay. Apply that same concept to what we just did. if the first one equals D, and the second one equals D, what can you say about those two equations? They equal each other, don't they? They have to, mathematically. Okay, so let's write that out. Get going. There we go. So the first equation was, where is it here? 13 minus 2t1. And what does it equal? 23 minus 2t1 over top of 3. Oh, yeah. Now this comes back to grades 7 and 8. Proportions. This guy. What's that called? Cross multiplication. Do you remember that? All right, you can go on the diagonal and cross. Now basically, what is this 13 minus 2t1? What's it over? It's 1. Do we need to write it in? No. You often did that. Remember when you were doing trig last year? You often did that when you're doing the cross multiplication. You put it over 1 just to make life easier. So basically, it's 1 times this and 3 times this. So basically, that 3 is getting distributed to one of these or both of these? Both. Okay, so let's do the math. Okay, so we're going here. So 3 times 13 is 39. 3 times negative 2t1? Negative 6t1. What does it equal? 23 minus 2t1. Guys, this is just algebra. That t1, is it just a variable? Yeah, if you wanted to replace it with an x, go right ahead. But I mean, we're in grade 11. You don't need to be replacing it with single variables, right? You can use double variables. You can use variables with subscripts. Big deal. You guys are smart enough for that. Okay, what do you do? CLT. Collect like terms, right? Move everything around. Put all the t's on one side, put all the numbers on the other. Okay, what do you want to do? Let's move, what did I do here? Oh yeah, so we'll do plus 6t1, and what are we going to do with the 23? Minus 23, right? So plus 6t1, and we're going to minus 23, right? How'd your teacher ever, how do you guys do, no, what's the opposite of negative 6t1? Adding, right? We're trying to eliminate it. How did your teachers teach you stuff like that? Did you guys do it out in a single line, or did some of you do it that way with little? Does it matter to me how you do it? No. Some people put it on the top. Some people write out that whole next line. They actually write. Remember, you ever did that where the line is really, really long? Takes a lot of time. You'll get faster and faster with these. Okay. So these are gone, right? These are gone. Okay. What's 39 minus 23? 16 equals negative 2t plus 6t. Positive 4t. 4t1. Oh, wow, this is getting easier all of a sudden. What do we do now? Divide by 4. Divide by 4. What is the first term? 4. Oh, cool. Hey, yeah.
I did my own answer, but I just really didn't do that. I just like t equals t.
Yeah, well, that's what we did. You didn't simplify like we did, right? You can simplify here.
Oh, but it's
exactly the same. It's fine. It's fine. It's fine. Okay, now, you know that the first term is 4. Now, without even thinking about it, what's the second term? How do you know it's 9? What do the first two terms have to equal? 13. Oh, okay. So we know the first term is 9. So we know that, first term is 4. Second term is 9. What do they actually ask you? Determine the first 6 terms in the series. Is that what they asked? Okay. So let's just write it out. The easiest way to do this is when they ask you what the terms are, you just write them out. T1 is 4. What's T2? Now, what is it going up by? 5. Okay. So we know D. We'll just write that there. D is 5. We know that. Okay. What is the third term? 14. What is the fourth term? What is the fifth term? What is the sixth term? Okay. So there it is. Now, I can put a question to ask you, what is the sum? Well, could you just take all 6 of those and add them together? Yeah, you could. But we're going to do it mathematically. We're going to do it with a formula. Okay. Now, flip to the first page. Look at your formula. We want the sum of the first 6 of this one. Well, I got two formulas there. First formula should work, but that second formula just seems so lonely, doesn't it? It's all by itself. Do you think we can use that in this case? Do we know the first term?
Yep.
Do we know the sixth term? Do we know what n is? Yeah, so let's use that one. What the heck? Let's live dangerously. So we know, let's write that down. S of n equals n divided by 2, t1 plus tn. Beautiful. Why not? Let's use this one just because it's by itself. So we're trying to find the sum of the first six terms. So what's n? 6. What's t1? What was it? Thank you. What's the sixth term? Sixth term? 29. That's a 6 equals 3 times 33. 3 times 33 is 99. Could we double check that answer? Yeah, we could add up all 6 of those terms if we want to. Tough question? Extremely tough question, right? You're thinking differently, right? Yeah, but this is a great example. But I did the other two first because the 1 and 3 is what you're normally going to get. This is thinking outside the box. Yeah. Bonus question answer? Yeah, good. Just put that with the answer there and say, is this right? No, I won't. Okay, now, oh, geez, you got lots of time. Okay, so today, the rest of today, so you have half an hour, and I would recommend getting started on it. And all of tomorrow. Now, tomorrow, we're going to start mental math. Wah! We'll do that at the beginning of class, so don't be late. Quick, no calculators, get it done. Somebody wake up Van. I'll show you an example on the board in a sec. Just let me stop recording this thing. Hang on.